Hello, everybody. Welcome to Electrostatics, Charges, and Coulomb's Law. Today, we're going to go over parts of the atom and how different parts of the atom and different charged objects interact with each other. Let's begin. Okay, so there's a couple of things that we need to know about the atom. First off, we draw a very simplified version of the atom where it's a nucleus with a proton and a neutron. We don't go into the subatomic stuff. And surrounding the nucleus, we have the electron that you see on the left. So there's a couple of very important things about the atom that we will be using throughout this year. So let's take a look at these ideas. One, the proton is more massive and it always is considered to have a positive charge. The electron is less massive and has a negative charge. And what I mean by less massive, it's to a great order of magnitude. And that does show up a lot when we look at how different charged objects operate under certain conditions. And then, of course, we have the neutron. It's just as massive as a proton, and it has a neutral charge. We usually don't talk about neutrons, but occasionally it does pop up. Okay, so with these ideas, there's a couple of very important things that you'll see on the formula sheet. The very first line that we see here is the proton mass, MP, the neutron mass, Mn, and the electron mass, Me. These will always be on your formula sheet, so you don't have to really commit them to memory. However, we'll be using them frequently, so it does help to just at least have the base magnitude in mind, such as the mass of the proton and the neutron will always be 1.67, or sometimes you might see as 1.66 times 10 to the negative 27, and the mass of the electron will be 9.11 times 10 to the negative 31. So already right there, you can see that the electron's mass is a lot smaller than both the protons and neutrons. All right, on the right-hand column, we see the electron charge magnitude, where it's e to the 1 point, or e, which is equal to 1.6 times 10 to the negative 19 coulombs. All right, so I'm going to jot something down right here. It's important to know that the electron charge magnitude is something that we will be using a lot. Now, the idea behind the word magnitude is that this charge can be used for both a positive charge and a negative charge. So let's go over a couple things. First off, the variable for charge is a lowercase q. And sometimes if we are dealing with an electron or negative charge, I put a little superscript right there to show that it's negative. Or if I just leave it as a q, that could just be a positive charge. Okay. Another way that you can see the charges represented in problems is that if you have just an E with a negative, this shows us that it is a negative 1.6 times 10 to the negative 19 coulombs. And that is for a electron or a negatively charged particle. Or if you just see an E of 1.6 times 10 to the negative 19, that can represent a proton. Now, it's very important to know that the charge for electron and the charge for a proton is equal, but opposite in signage. And so if you have one electron and one proton, you have a completely neutral system. All right. And the very last thing I want to talk about is that the units, capital C. So this capital C represents coulombs, C-O-U-L-O-M-B, named after a very famous scientist that did a lot of work with electricity. Okay, now less so in mechanics, but definitely more in E&M. Units actually do matter. Okay, so we need to get into the habit of writing down units. Now, another thing I want to point out is the scientific notation. So we see here, I wrote it as negative 1.6 times 10 to the negative 19. Now, when we're doing problems, sometimes that's just a lot for you to jot down. So you might see me write the magnitudes as 1.6 times 10 to the negative 19. So instead of that, you'll see me write it as 1.6 capital E negative 19. Okay, and I always put that in parentheses when I put that into my calculator. Now, your calculator should have that function. It's not a lowercase e, but it is a capital E, and that just cuts down on the amount of typing that you need to do on your calculator, and when you're writing these problems down, it does reduce the amount of pen strokes that you have. All right. Okay, so we have that. Now let's go into the fundamental law of charges. Now this is something that you should have covered back in chemistry, but just in case, let's go over this. One, like charges always repel, and unlike charges always attract. Now, when I say like charges, the first one we have is a positive charge and a positive charge, or a positively charged object and a positively charged object. Those two objects will always repel, followed by the negatively charged object and a negatively charged object. Those will always repel. Now, if you're wondering, where can we see this in real life? Sometimes when you do laundry, this happens a lot with socks, especially during the winter time where it's a lot less humid and the air is very, very dry. Charges on objects tend to stay there more. So if you do laundry and you take out your socks from the dryer, you'll see that if you take off the socks and you bring them close to each other, they might have a repelling effect to other objects. Or oftentimes, if you take out objects from the dryer, you'll see that the socks are attached to your clothes. That goes into the idea of like or unlike charges attracting. So, for example, if we have a positively charged object and we have a negatively charged object, these two objects will attract. Or if you have, now this one's new, a neutral object. So when we are talking about neutral objects, this is a equal amount of positive charges and an equal amount of negative charges. Okay, so if we have an equal amount of positive charges and an equal amount of negative charges, we say that the two objects are neutral. So if you have a neutral object with a positive object, they will attract. If you have a neutral object with a negatively charged object and they're close to each other, they will also attract. Okay, now when we are talking about attraction and repelling, it's important to know that for repel, we will use the term push away or push, okay, where you are like repelling an object away, so you're pushing an object away. And when we talk about attract, sometimes you'll hear me talking about a pull, okay, where the two objects are pulling towards each other. All right.